For learning description, in this section, students deals with understanding the basic concepts of energy. We use energy in all its forms almost every day. Future engineers study these forms of energy to help create things that make our lives easier. For learning outcomes, demonstrate understanding on the basic concepts of energy, distinguishing the energy forms. Show understanding of the laws of thermodynamics.
Hello classmates! How it's going today? Whee! So what's up? Hey, ever wondered what energy is? Well, it is the ability to do work. Want to know more about energy? Come on then, zoom in. Energy can be found in a number of forms. When you eat, the body breaks down the food and gives you energy to work and play. But all of this energy was originated from a giant ball called Sun, which provides 99% of energy we use on Earth. When you go to school, you receive Sun's energy in the form of heat and light. And while coming back from playing, the street lights uses electrical energy to give you light. There are two main types of energy. First is the potential energy, the stored up energy which has the potential to do work. It is written in the formula of PE is equals to M times G times H. Next is the kinetic energy. Every moving object has energy. The energy that the body gets because of its motion is called kinetic energy. There are three types of potential energy. First is the elastic potential energy. Energy stored by things that stretch or compress, such as springs, elastic, or rubber bands. The second is the chemical potential energy. Energy stored in chemical bonds between atoms, for example in the Snicker bar, food, or even the gasoline. Last is the gravitational potential energy. Energy stored by things that one above Earth, for example a book sitting on a shelf, a person standing on a cliff, or a roller coaster period at the top of a hill. So, I am going to tell something that you must remember for the rest of your lives. Energy can neither be destroyed nor created, but it is transformed from one form of energy to another.
Different forms of energy. Energy comes in 6 forms: chemical energy, electromagnetic energy, radiant, mechanical, nuclear, and thermal energy. Mechanical energy. Mechanical energy is a substance or system has because of its motion and position. Mechanical energy stays along with both kinetic and potential energy which is available in the system. Every moving object has a mechanical energy, whether it's hammer driving a nail or a rocket flying in space. Our body also uses mechanical energy to perform motions such as throwing a ball
Or moving a pencil.
Chemical energy. The motive force that powers the human body is provided by the chemical energy derived through the process of respiration. Chemical energy is derived from the making and breaking of interatomic bonds in molecules. Electromagnetic energy. Energy from a magnetic field that is produced by the motion of electric charges such as electric current. Electromagnetic energy exists in the form of called photons. It is said to be the type of energy which comes from electromagnetic waves. This radiation travels with the speed of light and decomposes over radio waves, TV waves, heat, light, X-rays, visible waves, and others. The Sun, the Earth, and the ionosphere are main sources of electromagnetic energy in nature. Nuclear energy. Nuclear energy originates from the splitting of uranium atoms in a process called fission. When the nucleus splits, nuclear energy is released in the form of the heat and the light energy. Nuclear energy is also released when the nuclei collide at the high speeds and join. The Sun's energy is produced from nuclear fusion reaction in which hydrogen nuclei fuse to form helium nuclei. Nuclear energy starts with Albert Einstein his classic formula E is equal mc squared. Thermal energy, or also called heat energy, is the result of an movement of the tiny particles called atoms, molecules, or ions in solids, liquids, and gases. Heat energy can be transferred from one object to another. In measuring energy, energy is measured in joules.
Good day everyone. Today I would like to discuss about the law of thermodynamics. But first, let us know the definition of thermodynamics. Thermodynamics is a branch which deals the movement of energy from one form to the other, and the relations of heat and temperature with energy and work done is called thermodynamics. The key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. And now let us proceed to the law of thermodynamics. The law of thermodynamics is the most important lesson for people understanding mechanism behind, phase, and changes of matter. In physics, thermodynamics deals with the relationship between heat and other forms of energy. Heat is conserved. An example, it cannot be created nor destroyed. It can, however, be transferred from one place to another. Heat can also be converted to and from other forms of energy. Temperature is a measure of the average kinetic energy of the particles. Also, the law of thermodynamics defines the fundamental physical quantity of temperature, entropy, energy that characterize the thermodynamic systems. The most important laws of thermodynamics are the zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and the third law of thermodynamics. Let me introduce to you the zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are each in thermal equilibrium with some third body, it means that they are also in equilibrium with each other. This basically explains that if object A and object B are in thermal equilibrium with object C, then object A and object B are thermal equilibrium with each other. Thermal equilibrium means that if two bodies are brought into contact with each other and separated by barrier and permeable to heat, therefore there will no transfer of heat will happen from one to another. The zeroth law of thermodynamics says in essence that the three bodies are all the same in temperature.
So I'll be telling you more about the laws of thermodynamics. Did you know that the first law of thermodynamics is also referred as the law of conservation of energy? That is because the heat is a form of energy, and as a result, the principle of energy conservation applies to thermodynamic processes, meaning energy cannot be created nor destroyed. However, it can be transferred from one location to another and can be converted to and from other forms of energy. We can take a common example of a heat engine. In a heat engine, the thermal energy is converted into the mechanical energy, and the process is also vice versa. A heat engine's main working concept various interactions between heat, pressure, and the volume of working liquid, which is usually gas. The first law states that whenever a system undergoes any thermodynamic process, it holds a certain energy balance. But actually it has its limitations too. The first law of thermodynamics fails to demonstrate the capability of the system's process or change of state. To understand further, this will be explained why in the second law of thermodynamics.
So what is the best describes the thermodynamics? So the second law of thermodynamics gives more information about the thermodynamic process itself. It defines as heat cannot be flow itself from colder body to hotter body. So thermodynamics means hot things always cool unless you do some things to stop them. It expresses a fundamental and simple truth about the universe that disorder characterized as a quantity, known as entropy. Also increases, for example, when a hot object is placed in a contact with the cold object, heat flows from the hotter one to the colder one. Never spontaneously from colder to hotter. If heat were to leave the colder object and pass to the hotter one, energy could still be conserved. So as you can see in the illustration from the left image, the process can occur on its own or spontaneously. So the entropy increases, while on the other side, the process is non-spontaneous. So the entropy of the universe decreases.
Our topic is about the third law of thermodynamics. So what is the third law of thermodynamics? The third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. So as the temperature approaches outward zero, the entropy of a framework approaches a steady state. At outward zero, a system's entropy is regularly zero. So what is entropy? So entropy is the measure of the randomness of the system. So example, the bottle of the carbonated tray. When we shake it, we can see the bubble forming at the top of the surface, and when we open it, the bottle of the soda explodes. That forms a lot of bubbles, and that is the entropy. A bottle of soda that is at rest has a very low entropy, but when we shake, the kinetic energy will be introduced on the molecules inside the bottle that increases the disorder and randomness of the molecules. So the third law states that when a pure crystal is cold, approaching absolute zero, it becomes highly organized. Entropy approaches to zero.